Okay, just quickly in terms of resources, this is kind of important because you hear Manaaki Whenua, you hear soils, you hear about S-map, but you don't necessarily hear about all the supporting systems and infrastructure that we currently have. Legacy soil maps, reports and resource, National Soil Archive. So all the soil samples we've collect, if they meet a certain criteria, actually get stored for posterity. So we've got samples in that collection that predate the atomic bomb, so uncontaminated samples. Really important resource. National Soils Database, everything that we measure, observe, everything that goes through the soil labs, we've got 3 soil labs, in principle ends up in our National Soils Database. So again, that's a rich record, mostly of observed and measured. So like I said, 3 soil labs, pointing that out because those labs do types of analyses that we can't actually get commercially elsewhere. So it's kind of like for a research grade, for the types of analyses, particularly in the soil physics field, we kind of have to have our own soil labs. We have our own classification and methods, books up the front here if you want to have a look. So these are kind of the standards that we work to, and they are currently all being revised. And digital soil maps, I'll touch on that in a moment. As I said before, we have a lot of research underway. I'm not going to dwell too deeply on it today. The key things that show a lot of promise at the moment is the use of lidar for derivative surfaces and automated delineation of landscape units, and how AI is being used, and the soils portal. So I just wanted to mention the soils portal. Again, this is something that Thomas Kaspari leads or authors. Basically everything, if you want to know something about soils, the history of soil mapping in New Zealand, some of the challenges, all the details there. If you just type in soils portal, it'll take you to the Manaaki Whenua soils portal site. So it has a lot of information about soil mapping, but equally it's also a hub. So it hooks into all these other soil information resources that we have. Legacy soil map viewer, you want to see an old soil map, good place to start to see if it's been scanned. And even we have all this unscanned maps as well. So we have all those well documented now. Old fundamental soil layers, don't recommend it, but it's still there. It has complete national coverage. If you want soils data, all the data or landed soils data that we hold, you're competent in GIS, yep, that's where you grab it from. S-map online, I'll cover briefly in a moment, and yeah, a few other ones there, and all the old soil reports, bulletins, and that sort of thing. You're going to put your hand up, Simon. You're going to interrupt me? No? Anyway. Okay, but our flagship, as I mentioned, is S-map. Described online as the digital soil map of New Zealand. Like I said, it's our flagship. There's a lot of key principles in there. It's kind of like how I see it. Couple I'd like to point out. Yes, it is a fixed scale, so it's a nominal 1 to 25, 1 to 50,000 scale. However, some soils, some landscapes can actually be well represented at a scale of 1 to 25 to 1 to 50. You've got a boring soil, you've got big units, you've got uncomplex geology. It's equivalent to farm scale. Farm scale is a real misnomer. The other thing is, when we're out mapping, we do actually encounter many different soils, but because of the scale, we can't actually spatially delineate them or represent them with an S-map. We do record them, however. So we will record up to 5 soils per landscape unit, and yeah, we estimate the aerial coverage. So it's kind of like how we deal with scale. The other thing I'd like to point out is that S-map is just one thing we do. So I talked about all the other data sets and systems that we have. It's always all about S-map. Kind of feel obligated to cover S-map online. Like I said, it is our flagship project. And for those of you who, not everyone's familiar with S-map online, so I'll just quickly take you through it. The detailed side of things Lauren will cover. So it's an online resource, so the address is up there. 2 key things that I use it for, basically the mapping side of things and to have a look at the fact sheets. But to be honest, most of the time's actually spent in the map side of things. For those who have never used it before, have a look under the support tab. There's actually a whole host of guidance there on how to use and interpret the data that we serve up through S-map. This is a zoomed in version of what the interface looks like. So you can very quickly search for an address or a location. You can change the appearance by changing the layer. So we can flip to the soil order classification. For us, it's just easier to interpret, and it's all clickable. So you can click on one of those polygons, and among other things, it will pull up fact sheets. Two types of fact sheets. One, this is the new one, the soil map unit fact sheet. It's kind of an aggregation or a summary of all the soils that may be found within a given polygon. But the classic fact sheet are the soil sibling fact sheets. So I won't cover those because Anthony and Caleb will be talking about those later, or be giving some examples. Cool. Sorry, all a bit rushed, because now I'm going to hand over to Lauren, who's going to go through an actual project regarding soil mapping that we do.
Okay, so I'm going to take you through a project I did a couple of years ago. So that's the soil map for the Horowhenua Freshwater Management Unit. So it's basically the whole area surrounding the bin. It's part of the larger S-map expansion program. So it's joint funded between Horizons Regional Council and NPI. It was originally negotiated to be about 40,000 hectares. We played around with boundaries a bit once we got the elevation data, and came out at about 50 in the end because we grabbed a bit more hill country than we thought we would. So it's a total budget of just under 250k, and it was about an 18-month contract, slightly interrupted at the start by various COVID shenanigans, but it didn't hold us back too badly. This part of the world actually does have quite a lot of soils information to start with, which is nice. Doesn't always work like that, but the area's near Vic Uni, so like a lot of academics spend their field time out here. Geomorphology studies are available in the literature way back to 1918. Soils mapping from the 40s onwards. We've got fundamental soils layer in the NZARM from the 90s, and some recent neighbouring studies. So Alan Palmer and Hugh Wild did the neighbouring Otaki district in the 90s. As well as that, being in Landcare Research gives me a little bit of an advantage. I can get contract reports and various bits and pieces of unpublished data. Alan Palmer at Masterclass was kind enough to supply some of his site data for various projects he'd done in the area. And HRC also were very helpful in giving me some data from some of their farm scale mapping and also the groundwater bore data. I don't know if anyone's had a look at that stuff, but it does come with, it's not just the borehole log, it's some very basic soil description data. Not enough to really use for mapping from scratch, but enough to do some verification work. So because there was such a huge number of points, even though the data wasn't super high quality, it's quite helpful for making sure I didn't put a gravel layer where I shouldn't. So the first stage of mapping was taking in the spatial data that was available and producing a broad scale landform map. So it's only a couple of hundred units there, far too big to be useful for soils, but we can use this to plan and guide our field work and also to form a base for the eventual soils map. So that was delineated manually with the assistance of lidar coverage that was available across the lowlands. Unfortunately, in the hills, there's only a photogrammetry DSM, so it's still got all the vegetation, buildings and stuff in it. Not so great for calculating slope. It's really messy, but you can kind of see the general shape of the landscape at least. Unfortunately, if we'd had lidar across the whole area, we probably could have done something a bit fancier, but there's two different DMs smashed together with wildly different quality. It kind of limits what you can do to manual delineation. QMAP was also useful as a general guide for some of that boundary stuff, and also the imagery, both the current stuff and the past stuff. So there's mosaics going back to the 40s, and there's also the very loosely geo-referenced air photos on retrolens. It's quite helpful to see what's been done to the landscape in the past. So we put the recon map out, and then we used that to start planning that field work. So as Andrew mentioned, access to land can be a big issue. So we can only go where we're welcome. And between that and the budget and time constraints, basically what we do is try to select farms that have a good spatial spread across the whole map area, so they're not all clustered up at one end. And also that they, using that landscape map, we were trying to find farms that straddle at least 1 or 2 landscapes, hopefully more if we could, so then you can hit those different landscapes in one trip. We did have the luxury of being able to do day trips out of farming, which is fantastic. You don't often get that kind of easy access travel-wise. So we'd go down for the day with a couple of farms, go home, and a couple of days later after we've gone through the data, just sort of work our way through the landscape. In the end, we got a couple of 100 sites, and the green ones, there's a subset there that has some additional laboratory data that we paid for. So I get mid-infrared scans on all of my samples, trying to build up the data set for spectral library analysis, and then a subset of those I'll get particle size, maybe pH or peer attention. The samples I get analysed are ones where I need to confirm the soil classification, so it's always data to support what we're seeing in the field. It's a pretty ad hoc kind of data set, so its reuse potential is somewhat limited, but it helps us understand the landscape basically. Don't get distracted at the bottom of the slide there. The thing about going out on farms, the best practice for doing that at this kind of scale is that you try to hit landscapes and be logical about it. So you pick sites before you go out there. Trouble is, as soon as you get onto a farm, your plan falls apart, right? Something that's inaccessible, maybe the conditions aren't great in a few areas, or the farmer says don't go there. You'll start to see interesting things in the landscape you didn't realise were there because you can't see the landscape. One of the things you have to be careful when you're sampling soils at this scale, it's not to spend too much time on the interesting and weird soils. You have to get the trend of the most common soils. So that's probably one of the major challenges for field work behind all the other ones. Anyway, with all of that data, this is more like what we do at each site. So here's a pitch showing a lovely little pallic soil from the southern end. You see my data sheet down the bottom. I sort of set this up to record it to OneNote. We have an app to record our site data, but I'm not very good at using it, so I tend to still handwrite the old school way and enter the data later. So across the top, there's spatial information on that top row, and some basic data about where we were. Then I've got some landscape codes. The third row is all of our high-level S-map data, so you've got the NZSC, the family and sibling codes, and then down the bottom is the 4 soil horizons that we found and the descriptions of those, so upper and lower depths, horizon names, our functional horizon codes, and all the other stuff that our dear Milne standard demands of us. So that's basically what I record when I'm in the field. This is quite a thorough site. If I've started to see the same soil over and over again, these notes get briefer and briefer as previous. That's just a way to keep efficiency up. Once we've got a collection of sites like that, the next step is to generalise them. So you might have 3 or 5 or 10 that are very similar to each other, and they have to be built into a map sibling for S-map. So that takes all of that site data and turns it into, instead of point measurements, ranges basically. So instead of saying you've got a 0 to 20 centimetre AP horizon, you'll say the AP horizon on the soil is between 18 and 22 centimetres in most cases, that kind of thing. So they all get entered into the database, and then the second thing that we do is lump up spatially. So we build mapped units out of those siblings. And as Andrew said, we're allowed to tag up to 5 soils per polygon, per map unit, and a map unit can be used across multiple polygons. We tag them with the estimated proportion of the area we think they're likely to occupy, and we also tag them with some slope and landform information if there's a clear slope and landform relationship with the sibling, which there isn't always, but where there is, we can provide some extra information about where in the map unit you're likely to find a particular sibling. So once all those map units are built, these polygons are labelled with those map unit names. So that's how everything hangs together spatially. And this is how we got to our final map. So in the end, we came out with about 18,000 hectares of hills and mountains, 12,000 of the flat terrace country, 13 or so of that sand dune country on the coast, and a smaller amount of alluvial flats along the Manderson, Ohio River, and Kaltura stream. We exclude urban areas because they're a mess, and don't map the locals, don't like the feet. So that's that project. I've got a little show and tell at the end, so some of the soils and features we found in the landscape. So this is the fun stuff. The first photo you'll see on the left is an iron pan that's forming in the sand dunes down towards the Manawatu River mouth. And it's a function of having like a heavier soil texture over a sand, and the water table's just the right level to fluctuate through that texture contrast and cause ironstone to accumulate. The stuff is rock hard, so it had to be broken up to build the drain you can see in the background of the photo. The soil's not always like that. This is like the extreme end of the iron development. The traditional series name for it is, I believe, the Te sandy loam in the 1970s map. And it's usually just, you dig down about 20 centimetres, you find some crunchy iron, but it's easy to punch through. But that's what you get in areas where the water table's not fluctuating as much. So this was out near the edge of a big drop-off, so there was much more movement. The second photo is a sand dune soil from the Foxton dune. So that's one of the older, more established dunes. So you've got a nice deep A horizon. They're quite stable dunes, and some B horizon development below. But then at depth, it just goes back into grey sand. The third one sort of illustrates the pitfalls of trying to sample below the water table very quick. So that's actually a clay, and it's down near the banks of Lake Horowhenua, which basically used to be a bit bigger than it is. So around the banks, there's quite a lot of really heavy textures and some peat in the lower areas. So the last one there is some of the areas along the lower Manawatu still have big, deep peats from flax. But the extent of them is not as much as was on the FSL map from the 70s. So I'm not sure whether there was a misinterpretation or whether the peats actually disappeared over time. But mostly what you get down there now is just a glaze soil with maybe a little bit of organic on top. Up in the hills, we found there's a lot more clay soils up there and a lot more stone. So the profile on the left is what comes out of the hills basically. So it's a second terrace back on one of the side streams. So it's very, very stony, but it's still quite heavy textured. So there's a bit of a restriction on that unit. The photo in the middle is basically, so I talked about finding 3 transition zones between landscapes, but each of those borders is not hard. So soils overlap on those transition zones, which can make things a bit messy. So that one's actually, it's a sand dune, it's sitting on a loess terrace, and under it there's sand again, which is an old marine bench. So there's quite a lot of messy stuff around the edges. The last one is an example of a soil we don't really map very much because I only found 2 profiles in the whole area and I couldn't find a spatial pattern for where it's popping up. So this is called an ultim soil. It's a very heavy clay soil and it's quite low pH as well. And they sort of pop up in the foothills here and there and at the back of some of the older terraces just kind of randomly. So we don't know much about how they get to where they are, but they are known to occur all around the sort of Wellington region of the lower North Island. They're quite common around Nelson and Blenheim as well. So that one, because it's so rare, I'd only mapped it on 1 or 2 map units. I put it in as 10% low confidence, so you might find it, you might not. So that's kind of how we try to deal with some of that ambiguity about rare soils. Yep. So that is all I have to say, and we're going to hand over for the activity now.
Alan and I actually went out on this farm and had a bit of a race. I'm a bit ashamed to say a man twice my age bet me on the amount of holes he could do. But we mapped a whole series of points. This is just a few of them. And we didn't expect you to get this, but you can break it down to this level. And so essentially what we had was on the far eastern border in that light grey area, there is a surface. It's the edge of a terrace surface, and that has mottled argillic pallix, which is, I'll show you what soil that is next. And then as you start to move across, you go through this nice progression into glaze. So you go from imperfectly to poorly drained. And then if you jumped onto the other side of the stream channel there, you'd go straight into peats. But if you backtrack a little, you start to get in a transitional sequence where you go from glaze to peats, and there's something in the middle which is essentially peats over glaze, which is a peaty orthic clay. And it kind of just transgresses from one side to the other as you get closer to the mouth of the lake. And you want to hit the next slide. So those are the map units, and then if you go again. Yeah, so this is kind of what the soils would look like if you had them in order. So again, if you went from east to west, from right to left, those were the soils you would get. And the 4 at the top there fall really nicely into each of their own classifications. But I was a bit mean and I chucked in a couple of trick ones. So depending on how familiar you are with soil classification, you could put those maybe in either group, because that's what they are. They're kind of sitting between 2 particular types of soils, and that's something that we see often, and it's something you have to remember when you're mapping soils and at the scale you're at, and then you have to stand back and try and group that. So for us, when we're mapping, we have to try and think about, we see all these soils, but at our scale, how many can we represent? How complex is it to represent all of them? And is it useful? But again, it just comes back to scale. At farm scale, this would be perfect. At S-map regional scale, this would be a little bit too much. And so we'll skip to the next one, which is the end result. And you can see we did manage to get 3 units. So that light blue area is the end of that Q2, Q3 last glacial surface, which has pallix and brown soils on it. And then you step into a skinny blue one, which is your transitional, which is dominantly glaze. And then the dark blue, which comes right up from the head of the lake, that is dominated by organic soils and glaze. And so that's just a little bit of a mind exercise to think about how we go from what we see on the farm to having to cluster soils together and put them into map units, and how we represent that on a map. And yeah, that was the exercise.